Hello, in this video series, we'll show you a step-by-step guide on tips for building custom chatbots. So to start off, initial and very important consideration is trust and safety, right? In other words, we must ensure that these chatbot applications stay on topic, right? For example, a ticketing chatbot for an airline should not be responding to politics. So here's what we're going to do. We're going to use Labelbox to identify prompts pertaining to politics. And then we're going to use these examples to set up the guardrails for our chatbot implementation. So we're going to load in your historical archives of conversations. In our case, we're going to use the Ultra Chat dataset. So to start off, let's use semantic search and some other functions to cast a wide net, right? We need to narrow down our prompts to things that we might think are related to politics or different intentions. Furthermore, we can use foundation models on top of those broad set of results to narrow down our results. And then we can use human loop methods to do a final verification of our classified intent before sending these examples to our LLM trust and safety guardrails. So let me show you how this works. Now I'm in my Labelbox environment. As you can see, here is the home screen. Let's just quickly navigate over to the catalog component. And from here, you can see my repository of all unstructured data across my enterprise. This can consist of text, but we can also load in PDFs, pictures, images, as well as other types of formats such as HTML files. So as you can see here, I went ahead and loaded in a subsample of the Ultra Chat prompts that I found on Hugging Face. It's a repository of 1.1 million conversations, but in our example, I just loaded in around 100,000 prompts. First challenge here is let's go ahead and use some semantic search and similar functions to get a general subset of all the prompts that I need that may or may not pertain to politics. To start off, let's go ahead and try out our natural language search, which takes advantage of the underlying embeddings for each corresponding data row. So in our case, we can simply look for politics and opinionated text, and it's going to look for similar text or embeddings across my data set of prompts here. And you can see here the most pervasive prompts that relates to politics or opinionated text are now surfaced to the top. Now we can combine this with additional functions, such as the find text function, where we can simply use a brute force method to look for additional text of relevance. So in this case, it could be politics, political, or anything dealing with opinionated text. Furthermore, we can increase the confidence threshold. So of the 100,000 prompts, we have now identified 685 of the most pervasive prompts that deals with politics and opinionated text. So now let's save our findings as a slice. So now this subset of data is available to my organization for further processing down the line. So we can call this political prompts and save. So with this slice created, let's go ahead and use some model Foundry and human loop approaches to distill this wide net of political prompts. So to do so, let's head over to Annotate, and we're going to create a new project. We're going to use the text data type and give this a name. So political prompts. Let's go ahead and save our project and add data to set up the ontology. So for the data set, we can point towards our slice that we have just created. We'll select all the data rows and queue up this batch. Once this has been finished, let's go ahead and set up the ontology. The ontology sets that guardrail as to what information you want to extract from each data row. So in our case, it's whether each data row is political or opinionated. So you can see here, I have created an ontology already that we can choose. Let's click next. And you can see here that these are global classifications. So from your labelers, right, you can now see the prompt, and they can make an initial selection whether this is opinionated or political. Let's go ahead and save these changes. We can verify that our data rows have now been added to our annotation project. And before we ask our annotators to start the labeling process, let's go ahead and leverage Model Foundry to take initial pass at each data row. So let's go ahead and select all the data rows within our annotation project, and let's go ahead and predict with Model Foundry. As you can see here, Labelbox Model Foundry provides you a plethora of different foundation models that you can apply to generate pre-labels for your annotation project. So in our case, let's use the latest state-of-the-art Gemini Pro model to generate some pre-labels and determine whether each one of the data rows that we have identified through semantic search is indeed political or opinionated. So here's a customized prompt that I can provide to the model. We have the ontology already defined. And now we can generate a preview before applying the job to our entire project. So let's check out the preview first. As you can see here, Google Gemini Pro is able to quickly determine whether each text is opinionated or political. Quickly reviewing the preview, we can see here that the prompts generally match the predictions. So we're fairly satisfied with the initial results. Therefore, let's go ahead and submit the job and apply Google's Gemini Pro model to all the prompts within our annotation project. So once our Model Foundry job is finished, as you can see here from my data rows within my annotation project, we can now confirm that each data row now has pre-labels from our Google Gemini Pro model. We can confirm this by clicking on each data row and checking out the pre-labels. And now as an annotator, you can now start labeling each data row with existing pre-labels to do one final human-in-the-loop review process for each and one of your data assets. And now this ensures that each prompt that you submit now has the highest quality labels for determining intent, or in this case, determining whether a specific prompt contains politics. And now, once all of your prompts with pre-labels have been reviewed by your human annotators, we can now head over to the export section and export all of your labels containing topics, intents, in this case politics, to your chatbot environment. So for our example today, we're going to leverage the Nemo guardrails to set up specific guardrails to determine which topics a chatbot cannot answer. So let me show you how. So to start off, let's go ahead and bring in the Labelbox SDK and initialize the Labelbox client ID. Next, let's go ahead and use the export v2 function to export all of our labels within this one line of code. As you can see here, it's going to return your labels in a JSON format. Therefore, we're going to parse it out. And in our case, I've created a pandas data frame. So you can visualize for each row, we have the data row ID that we can always reference back. The prompt, in this case, it should be political, and whether our human loop annotators has agreed with that initial assumption for politics and opinionated. So here are some of the sample prompts, and we can now take these prompts and add them to our guardrail configuration. So as you can see here are the list of prompts that our annotator has determined to be political in nature from our initial data set of 100,000 prompts. And whenever a user asks us similar questions to the ones above, your chatbot is going to respond with this following message. So let's test this out. So we're going to use a foundation OpenAI model, which we're going to fine tune and fit with our own model in a later video series. And as you can see here, let's go ahead and configure this chatbot with these guardrails. And if I ask something that's political in nature, it's not going to answer that question because we have successfully determined the intent. However, If we ask something else that is not political, it's going to help us answer the question. So hopefully in this video, we have shown you how you can take your historical archive of different prompts. We have used semantic search and other labeling functions to cast a wide net of potential prompts that may deal with politics. And then we used foundation models in combination with human loop approaches to ensure that each prompt deals with the topics or intentions that you're looking for, in our case, politics. Thank you.